Blurb 8, How to Read Analog Instrument Scales. In the last video blurb, we discovered that all measurements are uncertain in their least significant digit. Today's world has two different types of scale readouts, analog and digital. Although the number of digital scale instruments is growing, and by now is in the majority, there are still enough analog instrument scales to need to know how to read them. So let's take a ruler as a common analog scale example. Since we're using the SI measuring system in physics, let's use the metric side of this ruler. Suppose at the edge of an object, something whose length is being measured is indicated by the arrow in this view of a portion of the ruler. We could crudely call this measurement 2.2 or 2.3 centimeters. However, in order to gain the maximum significance from the ruler's scale, we must estimate to some value between 2.20 and 2.30. And to make this estimate, I recommend using a magnifying glass whenever you have a small scale. The way an estimate is made for an analog reading between two of its smallest division lines would be to imagine an arrangement like this, where the blue area and the green area represents 1/2 of the division distance. And you can see that the blue area left hand surrounds the 2.20 reading, and the green area surrounds the center line, which is 2.25, and the right-hand blue area would surround the 2.30 centimeters. You estimate if the arrow is closer to either the left hand or the center or the right hand division line by eye. In this case, the analog readout's least significant digit choices would be 0, 5, and 0. And you can see that the pointer is almost dead center, so it would lie in the green zone. Whenever a pointer or arrow on an analog scale lies between two of its smallest division lines, the estimated least significant digit is always 1/2 of that smallest division. Notice that plus or minus this 1/2 division estimate in an analog readout is the uncertainty of that reading. So for this example, the measurement with uncertainty is 2.25 centimeters plus or minus 0.05 centimeters. And that's how it would be written. Measuring instruments more complex than a ruler have what's called instrument error associated with their readouts. The uncertainty of a readout is then added to this instrument error in order to report the maximum deviation of the readout from a totally accurate value. When thus added together, the words uncertainty and error become mixed and ambiguous. Your course may just use one of these two words to indicate what amounts to a combination of both. Seldom are they kept separate and distinct in a high school physics course.